All right, so we are going to go ahead and get started. I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar, Cluster API, a Kubernetes subproject to simplify cluster lifecycle management. I am Ricardo Katz, Cloud Engineer Coordinator of Serpro, and I will be moderating today's webinar about one of the coolest Kubernetes subprojects, and I hope you enjoy also. We would like to welcome our presenters today, Katie Gamanji, Cloud Platform Engineer at American Express, and Naadir Jeewa, Senior Member of Technical Staff at VMware. Just a few important items to you before we get started. So during this webinar, you are not able to talk as an attendee. There is a question and answer box at the bottom of your screen. Please feel free to drop your questions in there and we will get to as many as we can at the end. We are going to finish at 9 a.m. Pacific time. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful, be excellent to each other and with your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page at www.cncf.io/webinars. And with that, I will hand it over to Katie and Naadir to kick off the presentation. Katie and Naadir, please.
Hello, everyone. My name is Katie Gamanji, and I am a cloud platform engineer for American Express, as mentioned before. 4 months ago, I joined American Express, and I am part of the team that aims to transform the current platform by embracing the cloud native principles and making the best use of the open source tools. As well, quite recently, I've been elected as one of the TOC, or Technical Oversight Committee member for the CNCF. Alongside 10 other champions within the open source community, I'll be responsible to steer and maintain the technical vision for the CNCF landscape. Pretty much, we are the committee that leverages and enables projects to join the open source community.
And hi, I'm Naadir Jeewa. I'm a senior member of technical staff at VMware. I'm also a co-maintainer of Kubernetes Cluster API provider AWS. That's an AWS specific implementation we'll go into a bit later. I've worked with AWS for many, many years and moved into the Kubernetes space around 2 years ago. Yeah, that's me.
And today we're going to start the talk by giving an overview of Cluster API, but more importantly, giving an overview of the ecosystem that enabled Cluster API to be created or be a tool in the landscape. We're going to follow this by a technique to how Cluster API achieved the clouds, as well as how the declarative feature is a feature of Cluster API. Of providing a demo of how Cluster API can be installed, as well. If my demo is going to work, we're going to give an overview of how Cluster API can be used in association with GitOps model. And we're going to conclude by giving an overview of the roadmap and how can you contribute and get involved with Cluster API. So without any further ado, I would like to give an introduction of the ecosystem that enabled Cluster API to be created. If we go back 6 years ago, we had plenty of tools that provisioned container orchestrated framework for their capabilities. Some of these tools are going to be Docker Swarm, Apache Mesos, CoreOS Fleet, and Kubernetes. And most of them provided a viable solutions to run containers at scale. However, in the last years, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly for its approach towards declarative configuration and automation. And this prompted for a lot of users to get involved around Kubernetes. Based on its open source nature, more than 58% of the companies are using Kubernetes in production system. Now, this is based on the CNCF survey last year in 2019. It's worth to mention that over 42% of the surveyed companies are prototyping Kubernetes as a viable solution to move forward. Another milestone I would like to mention here is that more than 2,000 companies of the surveyed companies are using Kubernetes in an enterprise system. Now, this showcases the maturity and the high adoption rate for Kubernetes. When it transition towards the development community, more than 2,000 engineers are actively collaborating towards feature build-out and bug fixing. And when we look into the end user community, more than 23,000 attendees were registered at the KubeCons around the world. Now this is going to be KubeCon in Europe, China, and North America. And this flourishing community around Kubernetes has been extremely beneficial for this tool, because over the years, multiple tools were built around it to extend its functionalities. And this created what today we know as the cloud native landscape, which resides under the CNCF umbrella. Now, if you look into all of this tooling, some of them are going to focus on the networking functionalities, runtime. Most of them, especially lately, are going to focus on the cluster provisioning. And this is where Cluster API can be incorporated. And this is going to be the main topic of today's webinar. If you're looking into the ecosystem at the moment, there are a plethora of tools provisioning a bootstrap capability for a cluster. Some of these tools are going to be known such as kubeadm, kubespray, kops, tectonic, and many more. There are more than 100 tools provisioning a solution to create a cluster at the moment. However, if you look into every single tool, it's going to be difficult for us to find a common denominator when it comes to the supported cloud provider. What it actually means is that every single tool is going to integrate with a subset of existing cloud providers. And this actually imposes quite a few challenges. Supposedly, as an end user, what happens if you'd like to migrate your infrastructure to a different cloud provider? Even if you use the same bootstrap tool, you're going to have very little reusable components across different cloud providers. Usually the end result is going to be rewriting your infrastructure as code from scratch. Again, think about what happens if you'd like to migrate your bootstrap tool altogether or to use a new tool. In this particular case, Tectonic, which I introduced earlier, is no longer under active development, and it is to be merged with OpenShift Container Platform. That means that all the clusters which were using Tectonic to be provisioned cannot do so moving forward, unless the project is not forked and maintained in-house. Usually, if you use a new tool or you migrate to a different tool, the result is going to be rewriting your infrastructure as code from scratch. And another challenge is imposed by areas such as China and sometimes Russia. And this is because if you'd like to deploy infrastructure in these regions, it's going to be quite challenging. And this is because these regions have their own tooling to provision infrastructure out there. Most of the time, as an end user, you lose this capability of lifting and shifting your cluster across different regions, especially in China. However, Cluster API intercepts all of these challenges and provides a solution for all of them by giving a set of declarative APIs for cluster creation, configuration, and deletion. When we're talking about Cluster API, we refer to SIG Cluster Lifecycle, which had its first initial release in April 2019. Since then, they had 2 more releases, and they are now in a V1 alpha-free API endpoint. Now, I was mentioning that Cluster API integrates with different cloud providers, and currently there are 14 cloud providers that actively collaborate and integrate with Cluster API. We're going to have the support for some of the major cloud providers, such as AWS, GCP, and Azure. But on the other side, we're going to have the support for bare metal providers, such as Packet or Metal Free. But more importantly, we're going to have the support for Chinese cloud providers, such as Baidu Cloud or Alibaba Cloud. And this is extremely empowering for an end user community, because Cluster API enables us to create our clusters in China with the same ease when we do so, for example, in Europe or in the US region. Let's look a bit into more details of how Cluster API works. Supposedly, you have a task or project to create different clusters in different cloud providers, different regions. The first step you're going to need to achieve is the creation of a management cluster. For testing purposes, it is recommended to use Kind to provision the management cluster. And Kind is pretty much a Dockerized version of Kubernetes. If you'd like to use Cluster API in production, if you're one of the early adopters, it is recommended to use a fully productionized ready cluster. And this is because it comes with a more sophisticated failover mechanism. Once we have our management cluster up and running, we'll require the controller managers or our dependencies on top of it. And so far, we can distinguish 3 categories when it comes to the controller managers: the Cluster API CRD controllers, the bootstrap providers, and the infrastructure providers. Cluster API introduces 5 new customer source definitions, and there's going to be cluster, control plane, machine, machine set, and machine deployment. And we will need a controller for every single resource to make sure that we can create and reconcile any changes we have to these resources. The second controller we're going to require is going to be the bootstrap provider. And this is the component that translates the YAML configuration into Cloud Init script, and it will be able to attach an instance from a cloud provider to the cluster as a node. Currently, this capability is supported by kubeadm and Talus. And it's worth to mention here that the bootstrap provider will manage the control plane, which is a new resource introduced in v3 of Cluster API. And the last controller we're going to require is going to be the infrastructure provider. And this is going to be the particle which actually interacts with the APIs and provisions our infrastructure, such as the EC2 instances, well, not necessarily EC2 instances, subnets. If you have any security groups, IAM roles you would like to attach to your machines, all of these are going to be created for this controller. It is worth to mention that if you want to create multiple clusters in different cloud providers, you'll require a controller for every single those cloud providers as well. And once we have our controller managers, once we have our dependencies up and running, we'll be able to provision our target clusters. And these are going to be the clusters we're going to provision to our developers and our users are going to connect to. To make a comparison of the current way of bootstrapping a cluster and the capability that Cluster API provides, I'm going to showcase kubespray. And kubespray is a tool that uses Ansible underneath to provision the infrastructure as code. In this view, in this particular view, it's a trimmed output of all the Ansible roles a developer will need to be aware when creating, configuring, and managing a cluster. Cluster API completely rethinks the management of and the lifecycle of a cluster, and it reduces it to a couple of manifests. As such, if you'd like to create a cluster in AWS, this is going to be one of the manifests you're going to be requiring. In this particular instance, we're going to have a cluster CRD, and this usually is going to create all the networking components necessary for a cluster. As you can see in our spec section, we choose a /16 for our pods. As well, in the first line, we can see that this particular CRD was created in v1 Alpha 3, which is the latest version of Cluster API. As well, with the new version of Cluster API, we're going to have the control plane reference, which is going to manage our masters. And we're just going to link a template towards that configuration. However, from all of this manifest, I would like to draw your attention towards the infrastructure reference, because this is the component which actively integrates with the cloud provider APIs. With the infrastructure reference, in this particular case, we're going to create it in v1 Alpha 3 endpoint, and we're going to have a kind AWS cluster. What's going to happen underneath is actually going to invoke the parameters which are very specific to this cloud provider. As such, we say that we would like to create our cluster in the region U Central 1. As well, we say that we'd like to attach an SSH key with the name default. Again, this is just an example of the variables we have. We can have a deeper customization of our cluster as well. Now, if you'd like to create this cluster in GCP, these are going to be the only changes required. As you can see, we can reuse our cluster CRD, but we just change our infrastructure reference from AWS cluster to GCP cluster. And this in itself will invoke the configuration which is specific to GCP. As such, the region naming is quite different in Google Cloud, and we're going to have the name Europe West 3. We have the concept of a project, which again is quite specific to GCP, and we associate our cluster to project CAPI, and we attach a network by giving its name, default CAPI. And if we want to take this a further step to actually showcase the simplicity for using our manifest, this is how we're going to create a cluster in Azure. Again, we just change our infrastructure reference. The kind is going to become Azure cluster. And this in its turn is going to invoke the parameters for that particular cloud provider. As such, the location is going to be of West Europe. We can specify our network name, and we can even specify a resource group if we need to. You pretty much get the gist of it, of how simple it is to use a manifest and really tailor your cluster for via the YAML configuration. And over time, this has been a very efficient and very effective project. And this is because Cluster API uses the building blocks principles. It does not concern itself with actually integrating with Kubernetes source code and consuming its capability that way. It actually builds on top of the existing primitives. Another important feature for Cluster API is the fact that it's cloud agnostic. It is actually creating this one interface that allows you to connect to different cloud providers but most importantly, you can switch between cloud providers by having minimal changes to your manifests. And the last thing I'd like to mention about Cluster API, it's currently under assiduous active development. And if you have a use case for Cluster API, please give it a try and feedback to the community. Now is the perfect time to customize Cluster API to your use case. And at this stage, I'm going to pass the torch to Naadir, who's going to give a more kind of technical deep dive into how Cluster API was developed and the motivation around it. I'm going to stop sharing my screen.
Thanks, and I will change. Okay, hopefully that's working for everyone. I'm going to go into sort of how we built Cluster API to sort of achieve this cloud agnosticism, and why we think building clusters in this way is the right way to be deploying Kubernetes clusters. So if we think about a Kubernetes cluster, there's a bunch of components that we need to have running. We need to have like the container runtime, whether that's containerd, cryo, or something else. We need to have etcd as the backing store for Kubernetes. We need to deploy the API server. We need to manage the bunch of microservices that make up a Kubernetes control plane. And we need to manage the lifecycle of those. We need to, how are we going to ensure that upgrades happen, right? So Cluster API is really meant to design this, solve this problem once and for all. Like we've spent the last couple of years reinventing Kubernetes installers, and we should stop doing that and sort of move on to the sort of the deeper challenges of like how you build cloud native applications within an organization. We want to take away that frustration of just managing Kubernetes cluster and help organizations move to developing applications. So first thing we need to do is like bootstrap these components. So instead of reinventing the wheel, Cluster API is built in layers, and that this initial layer is kubeadms. kubeadms project that's been running for a number of years within SIG Cluster Lifecycle, and it's started life as a command line installation tool that you could run on a machine, and it will bring up a control plane. We actually use kubeadm inside Cluster API to create Kubernetes clusters. The great thing about this is kubeadm is almost like the canonical Kubernetes installer. It produces conformant clusters. Therefore, any cluster that's built with Cluster API, which is using kubeadm underneath, is automatically conformant. Within reason, you need to get the networking infrastructure correct, but apart from that, we are not doing anything new in this regard. So the next thing we have to think about is this other aspect of getting a working conformant Kubernetes cluster is that underlying infrastructure, right? So Kubernetes is plugging into load balancers, it's plugging into different cloud provider infrastructures. So we need to get that running in a certain way. And this is the bit where we're using kubeadm to bootstrap Kubernetes and take care of setting up etcd in this data store. And then Cluster API is creating machines and creating firewall walls in the infrastructure layer. And that's kind of how we see Cluster API being used, is just another layer. Like there's, I'll go into it in a minute, but Cluster API is essentially a Kubernetes API for provisioning infrastructure. So this enables you to then build your own layers on top using your standard Kubernetes mechanism. So if you're using CI/CD that's knows how to manipulate Kubernetes objects while using Cluster API, that CI/CD system knows how to deploy clusters in different cloud providers or bare metal or virtual machines, right? So it's about giving a consistent interface that you don't have to learn anything new. It's not a new bespoke proprietary interface. It's your standard. You can use all of that tooling that you built for your application development. You can apply that again to managing your clusters. And that's why, you know, there's interest in it. So in terms of the people who are involved, we've got loads of organizations are building layers on top of Cluster API. So, you know, VMware, Microsoft, New Relic. So we have a lot of community participation, and this really helps us build something that can work for everyone. We take away that strain that if you're in an organization, you're tasked with building out a new Kubernetes infrastructure. You don't have to build all that infrastructure as a code. You don't have to write your own Terraform manifests again. It's like, let's give you a way to download the tool, use it. It's got lots of people working on it together who know, like, this is the best practice in this sort of environment, and that all of that work's been done for you. So as Katie was talking about, we have these abstraction cluster API, and what we've done is we've sort of mirrored the way that Kubernetes works, right? So a machine, if you think about it, is analogous to a pod in Cluster API. So we have a machine controller, and I'll go into a bit in a moment about what that means specifically, but a machine controller is managing individual, in AWS EC2 instances, in vSphere it's going to be managing individual VMs, right? And that's all it does. Doesn't do anything else. But then we have a machine set controller, which is similar in Kubernetes to the replica set. So replica set, you say how many copies of a pod should exist, in much the same way machine set says how many copies of a machine, well, how many machines should exist with a particular configuration. So same idea. So we're reusing those Kubernetes models in Cluster API. And a deployment works in much the same. So we have a machine deployment, which is able to scale down one machine set and scale up a new one. So we can do things like upgrades. And finally, this is something new that we did for V1 Alpha 3, which is the introduction of the control plane. So this is, in a sense, I guess, the most analogous thing is a stateful set in Cluster API, but it's specifically interested in how do we manage the Kubernetes control plane itself. So is etcd healthy or not? When we do an upgrade, is this etcd version changing? What other things need to happen in this cluster to migrate from one version of core DNS and kubeproxy to another? So the control plane controller is going to take care of those day two operations, right? So you started off with a small cluster, but now you've got lots of teams developing applications. You need to make this control plane bigger and more stable. Well, the control plane controller can help you do that. So the nuts and bolts of how these controllers work. So this, the Kubernetes model, I guess, is this sort of control loop model. So you declare a resource on Kubernetes, and it states the desired end state, and then the controller is viewing some aspect of the world. It's checking what state it's in, and then makes changes to that world to make it more in line with the desired state. So this is quite different, right, to traditional infrastructure provisioning. If you're used to using traditional infrastructure management tools, what you're having to do there is sort of declare a sort of graph of interrelationships. My EC2 instance depends on this subnet, and so I need to ensure that this subnet gets created before this EC2 instance. In Cluster API, we're not doing that. We have individual controllers. They're just interested in their small little area of the world, and they'll try and do what they want to do. And if it fails, that's fine. They'll come back and try it again later. And this turns out to be quite a powerful model for building distributed systems. And this is used throughout Kubernetes. And because it's been successful in Kubernetes, we've specifically taken this to infrastructure itself, infrastructure provisioning. So doing the same thing. So this means that when you want to allow users to create clusters across different cloud providers, they don't have to reason about all of those various components that make it up. They can just declare it once, and we use eventual continuous reconciliation to eventually reach the desired state. And that's basically how, in this management cluster, that you have different infrastructure providers which are installed. Each of those are doing this reconciliation for their individual little small area of focus that they're interested in. And then that together, out of that emerges your sort of fully working cluster. So what I'm going to do now is I'm going to do a little demo. And so what we're going to do is, because Cluster API requires, Cluster API is built on Kubernetes, so therefore we need Kubernetes to run Cluster API to create Kubernetes clusters, right? We love Kubernetes so much, we put Kubernetes in your Kubernetes. So, which is a bit weird, right? So what I'm gonna do is just gonna exit this presentation. And right, so what I did earlier is I created a Kind cluster. As Katie mentioned, Kind is a sort of a way of running Kubernetes on your desktop. It uses Docker, so it's and it builds a sort of nested Kubernetes control plane. And what I did next is I just initialize. So you can go to our quick start guide, which is at clusterapi.sigs.k8s.io. And I'm just basically going to run through this. But from here, you can download everything I'm talking about today. So what I'm doing is just initialize the vSphere provider. So this cluster cuddle tool takes care of all of the different components of Cluster API. So you're not having to do kubectl apply fs of various manifests from different GitHub repos. Cluster cuddle has all of that knowledge built in. It knows where to go onto GitHub to get the latest releases and install them. So what I've done is I've installed the vSphere one, but just for kicks, I'm going to also install the AWS one as well into this same cluster. And I will also show you this. So, and what that's done is it creates a namespace for each infrastructure provider, and it installs its sort of controller. And yeah, so I now have this AWS controller running. And then the next thing I do is configure a cluster. Oh. Just remind myself how to do it. So yeah, we go. So I'm just saying I want to create infrastructure. I want to create a vSphere cluster. I'm going to give it a name of vSphere test. I'm also going to just create an AWS cluster. So I'm just going to put these into YAML files so we can look at that. So it just will print out to screen a template. So the way to get this template working is you can either set environment variables, or you can edit a file in your home directory. So .cluster API and this clustercuttle.yaml. So you can either present these as environment variables or as a YAML file. And this is just basic information that you need just to get started. If you there's nothing to stop you creating your own templates, and there's nothing to stop you using any of your standard Kubernetes management tools to create clusters, right? So the clustercuttle config using the templates that come from GitHub are just the way to get started. And that just has created 2 YAML files which define an AWS cluster. It used my environment variable saying I wanted to use US West 2. It's done some sort of templating of, I'll make this bigger actually, sorry. It's done some settings around what kubeadm needs to provision to AWS, the version which I had in my YAML file, and I'm also just going to change some of these. I'm going to have a 3-node. So I have this kubeadm control plane, going to make that a high availability control plane. And I'm also going to have 3 nodes in as my sort of agents, sort of my compute nodes, if you like. I'm going to do the same for my vSphere one. I can find it. There you go. So I'm now ready to apply these, and that's standards. And that's 2 clusters which are now defined. So I've just got an alias for K to kubectl, but kubecontrol. So I have two clusters which are in a provisioning state, and show you what's happening on my infrastructure. So show you on vSphere first of all. So it's created a load balancer. So this is going to be my entry point into my Kubernetes API server. And if I go to VPCs, it's started creating the resources that are going to make up this Kubernetes cluster in AWS. So by default, we create VPC for every cluster. But if you're in many environments, you're going to have your own AWS infrastructure already. So in that scenario, you can provide those identifiers within the manifest, and then it will use your existing infrastructure to provision that cluster. So I'm going to continue working with the vSphere one because the AWS one takes a little longer because some of their VPC provisioning is takes a while. So as you can see in this vSphere environment, I've got my first control plane node that's come up, and as those instances come up, I'll have my Kubernetes cluster running. As we wait for those, are there any questions so far?
Right. So you want to know if there are questions, Naadir? Sorry.
Yeah.
Okay. So we got some of them.
Quick interruption here. Before we move to all the questions, I have a GitOps demo of Cluster API as well, which we can do.
Oh yes, that's right. So
shall we proceed with that? I think it's going to be a good, nice continuation.
Let's do that. Rather than waiting for me on my cluster, I'm going to hand you back to. So what I've just demonstrated is like how to get going just on your own individual computer, right? So but we need to think about what the day 2 operations here are, and I'll return back to that in a minute. But in your production environments, you're going to be using a long-lived cluster that's going to have these cluster API resources. And then now you can start to do your configuration management across all your teams in your organization. So I'm going to hand back over to Katie to show an example of what this might look like, not just as me as a developer who's building cluster API, but as someone, as an end user who is doing as a real consumer of cluster API. Thanks.
Let me share my screen. Sorry. Please let me know if you can see my screen. So a nice continuation. Yeah, cool. A nice continuation of the previous demo was, okay, we have a cluster. What do we actually see around it? So in this particular case, I'm going to showcase AWS, and it's nothing different from what was showcased previously. I'm just having a cluster in AWS with 6 nodes, from which 3 of them are going to be actually 5 nodes, because I'm going to have 3 of them being my control plane for my masters, and I'm going to have another 2 to be my worker nodes. Now, when I'm connecting to that AWS cluster, I'll be able to actually see this in a more native way to Kubernetes. So if I get all my nodes in my new cluster, again, I'm seeing 3 masters, 2 nodes. Now, what you see in the bottom output is going to be the machines, which is a CRD provision by Cluster API. Now, previously you've seen that all of these cluster, well, the entire cluster, it can be described in manifest. If we have manifest, if we have YAML configuration, we can make the best use of models such as GitOps, because we can really have this concept of cluster as a resource. So that's exactly what I've actually done here. I'm going to use Argo CD, which is something we prototype at the moment for our CI in American Express. And Argo CD is known for its kind of standards to deliver this GitOps model, which sees the Git repositories as the source of truth, or kind of describes the desired state of our usually resources, but now we can have a description of our infrastructure as well. So what I've done here, I've wrapped all of the manifest provision by Cluster API into a Helm chart. And I am going to showcase that. It's instead of having one ginormous file, it's going to load. I separated that into the different files. So for example, our cluster CRD is going to be something like that. We're going to have a CIDR file pods, which we can template because it's a Helm chart. We can template it further. But what I chose to template out of all of this is the amount of nodes for our control plane and the version for Kubernetes. So this is going to be a very specific Helm way to consume these values. As well, if you look at the replicas, I am pulling this from my Helm values as well. And if I look into, obviously, my configuration file, currently I have 2 workers as described. We have 3 masters, which is our control plane, and we have a particular version of Kube. So in this GitOps model, what I actually would like to showcase is how a change within our Git repository is going to kick in a process or an action for our cluster to be actually to add an additional node. That's what we're going to achieve today. So to do this, I'm going to go to my values file, and I'm just going to change my amount of replicas to 3. I'm going to commit that with a test message, and I'm going to push it. With the Argo CD, that's going to be pushed. Nothing interesting here to see for now. I'm going to go back to the Argo CD view. In this particular case, if I click on this, this is going to be all the resources that I'm currently creating for a cluster. And most of it, for example, we're going to have our machine deployment, which is going to be for our worker nodes. I'm going to have my kubeadm control plane, which is going to be for our master nodes. But what we're really interested in is currently, we can see that we have for our MD stands for machine deployment. We have 2 machines here. And instead of actually waiting for Argo CD to get that pull request, I'm going to force it by doing a refresh. So now what it's actually going to do is going to look into my repository. It sees that the amount of replica is free, and it's going to create a new resource. What's actually going to happen underneath, we can showcase this in our view. So we can say new machine is being provisioned. And if we take it a further step, and if we look into our AWS console with a refresh, we'll be able to see that we have our new MD or machine deployment, our worker node being provisioned in AWS as well. And this is a very powerful concept, again, mentioning that we can really think about our clusters as a resource, and we can really even visualize our clusters using a GitOps model or a dashboard. Again, quite a powerful concept when you're thinking about your clusters as cattle rather than pets. And with this, I would like to pass it back to Naadir if there's anything else to show from the previous demo.
Thanks. And so whilst Katie doing a demo, so that, I mean, this is really how we expect Cluster API to be used in wild, right? So it's not so much using Cluster Cuttle in the palm line. So if you're going to the quick start, just be aware that the Cluster Cuttle way is not the be and end all of Cluster API. It's your entry point, right? And you should think about how to open up this power to the rest of your organization, right? Rather than having one gigantic cluster which has all of your applications in it. If it's so easy to create clusters, you can start to delegate the creation of these clusters to individual teams as well. Let them take control of those clusters, but also you can provide the sort of the policy and governance around them as well. So I've now got 2 clusters. So if I take a look at my control planes, so there's one thing, because that AWS one is taking a little while to come up, I won't be able to show you, is this idea of a move. So I will show this in the slide. So the move is something we did in V1 Alpha 3. So the concept of cluster cuttle move is to enable this idea that if you need a long-lived management cluster to be running cluster API and be managing all of these other workload clusters, then how do you create that management cluster? And what cluster cuttle move does is it can move the resources from your the bootstrap cluster that you created on your computer. It can move all of those resources to the cluster you just created, and then that cluster can not only create new workload new clusters from itself, it can also manage itself. So there's quite a few organizations who use Cluster API in this way, that they all of their clusters are basically self-managed. And they can also upgrade themselves as well, right? So this is really the new features that we brought into V1 Alpha 3 through the stateful management of the control plane. If there's time and my AWS decides to let me, then we'll do it. But that's basically how the cluster cuttle move works. If you want a long-lived management cluster. Yeah, so we've done that. So talking about the future, right now we're really focused on managing the control plane better. So we did an initial release now. It already does upgrades. It already knows how to introspect etcd to make sure it's healthy. We don't start trying to do an upgrade if your etcd is not working, for example. But we're working on bringing flexibility in how we do upgrades for those. If you need to reconfigure bits of the control plane, or you need to change a setting on kubelet, how do you manage that change? So the other things we're working on is improving observability. So we're starting to introduce the idea of conditions. So these are APIs that you will see on those resources, and then you can build management tooling from that, whether or not you want to ingest that into something like Prometheus, or you want to build some automatic remediation from that as a higher level tooling above Cluster API, then you can go ahead and do that. And finally, we're going to work towards stabilizing the API. So one thing to note is that the clusters that are created by Cluster API today are using kubeADM underneath. Therefore, they're like fully Kubernetes conformant clusters. What we're figuring out now is what are the use cases people want in terms of what they want from the cloud provider, support in cluster API, and then from that we will work to stabilize the API and move it in from alpha to beta. So in terms of what the release cadence is, we try and do it about once every 6 months. We do a minor release, and minor releases in this case follow that sort of Kubernetes model. There can be API changes within a minor release, and we have public planning meetings for those, which we'll mention at the end. We communicate through CAPs, so you can see all this in the GitHub repo. There's all proposals should have their own markdown document in there, and we're going to be iterating on the API and get that to completion. But the underlying controllers and infrastructure providers are robust today. They're ready for you to go and use. So I was saying, really big change in 0.3 v1 alpha 3 was the control plane controller. That everything I showed you around this cluster cuttle CLI tool was new. And we built documentation and book for that. And also for those who are interested in contributing, or you want to test other bits of Kubernetes, then we've built a test framework in Cluster API that allows you to plug in your own different tests to test different aspects of a Kubernetes in situ of a infrastructure provider. So which should be quite a powerful thing if you're working on things like load balancer integrations or things like that. Also new was machine pools. So if you want to use things like auto scaling groups and their equivalents in Azure, so machine pools is a new API for doing that. Machine health checks are a way of what to do when something's happened with a machine. It's a plug and model. You can define the checks that are required, and if they have failed, then those machines are marked as unhealthy, and then a decision can be made what to do with them. And finally, failure domains. So how do we make sure that control plane instances are distributed adequately across a data center? So we want a host in each rack, or we want it in a cloud provider, we want it in different availability zones within a region. Yeah, and then finally, if you want to get involved, we have a discussion forums. That's a Google group, so the links will be active in the uploaded PDF. So in terms of mailing list, we use the Kubernetes SIG Cluster Lifecycle Google group. We have meetings on Zoom at 10 p.m. Pacific, which is 6 p.m. UK time for me. So that's every Wednesday. We're in Slack on hashtag Cluster API. Yep, thanks.
All right, this is great. Thank you, Katie. Thank you, Naadir. It was a great presentation. We now have some time for questions, and we have a bunch of them, a lot of them. So I'm going I've consolidated some of them, and we'll put them here. So the first one is, the cluster being created is using standards VM, not Kubernetes as a service of each cloud provider as EKS, EKS, GKA. What are the pros, cons of using cluster API versus a managed Kubernetes service from a cloud provider? And if does cluster API supports AKS, or is going to support some of them?
I can take part of this question from the end user perspective. Why would you use Cluster API rather than go with a managed service by a cloud provider? This goes back to some of the challenges, because if you provide your infrastructure, for example, in AWS, and if you're going to use EKS, for example, it's going to be always there. It's going to be very difficult for you to transition to a different provider, or even have different flavors of it. You're going to be stuck with that cloud provider. If that's something which is all right for the business kind of resolution, that's absolutely fine. However, if you are in an ecosystem which is quite diverse, for example, if you have your infrastructure, you need to deploy infrastructures in different regions, not just Europe or not just US. You have to have replicas of your clusters all around the world. How do you manage that? And this is why I mentioned China, for example, because even if AWS is in China at the moment, well, it's gotten more mature, but most of, well, some of the products or services are still not available in China. For example, 1 year ago, actually 1 year and a half ago, like Route 53 was not available. Like you'd have to introduce your own DNS solution. So you don't have the same capabilities with the same cloud providers across all regions. That's what I'm trying to say. So Cluster API really enables you to, even if you cannot use the same cloud provider, you do some changes to your manifests because you can reuse them. You just put your own configuration from whatever cloud you want to move towards. And that's how you're going to provision your infrastructure in a repeatable manner. So it's all about longevity of your infrastructure and how can you manage it with minimal effort. It's all about that in major lines. And I think there was another question which was more, yeah, I don't know. That's my answer.
Great. Thank you, Katie. So we have some others here. Let me see. Is it possible to specify which load balancer to use when provisioning a Kubernetes cluster, or does it use one by default?
So today, it depends on your implementation. So for AWS, for instance, it definitely does create a elastic load balancer. We don't as yet allow you to plug in your own. We have been doing some discussion around the pluggable load balancer model, and there are the beginnings of that in the vSphere provider, just because if you're on an on-premise environment, there isn't a single load balancer solution. So we're still figuring it out. I would be really interested to hear what people would want from that, and then we can build the right API from that. But yeah, it's definitely something we would want to do.
All right, thank you, Naadir. So there is another one in the same line. Is there a plan to manage additional pieces of infrastructure, storage devices, load balancers, network, or storage switches?
Yeah, it's pretty much the same. I think we have to make a fine balance between being sort of a generic infrastructure as a code tool versus specifically we're mainly interested in the provisioning of clusters, but obviously there is some overlap and we need to figure out what that balance is. Again, like tell us, come to our meetings, create issues, tell us what you want, interested to know what you want, and we can build the right thing essentially. The things which are critical to a cluster, I think over time, those things will naturally become things that are managed by Cluster API, I think.
All right. Can I make some else's? That's okay. We have another one here. So what's here? Can I import an existing Kubernetes cluster in Cluster API cluster setup?
Probably not is the answer. Because specifically, if you look at something like the control plane controller, it expects the cluster to be configured in a certain way. It expects kubeadm to have been used underneath, and we use the way that kubeadm works to be able to manage things like the etcd control plane, the control plane components. So it becomes difficult because we would have to try and introspect how this machine was created to be able to figure out how to import it. That doesn't stop you from trying it, but your mileage will vary very widely.
Great. I'm going to make probably the last one here. So Are there any gotchas or best practices when one is going to implement an infrastructure provider?
Yes, and I would look at the book. So we've tried to codify what those contracts should be between the core cluster API components and what infrastructure components should be doing. There's probably bits which need a bit more detail. Come to the Cluster API meeting, talk to us in Slack, email Kubernetes SIG Cluster Lifecycle, where all of us are more than happy to help you start up a new provider if that's what you're interested in.
Great. So we have still 3 minutes and a lot of questions here. I will continue, okay? That's okay to you, Naadir? Great. So how do you usually manage the cluster that provision the other clusters? That one that you have provisioned in kind. Any recommendations?
Yes, so that's where you would use cluster cut or move to move those resources from that kind cluster into maybe your first created clusters. Your first step in your journey when you using kind and cluster cut is to create that initial management cluster and then move the resources. And so we have some logic to pause what the controller is doing, copy those resources into the new cluster, delete them from the old one, without any of your infrastructure changing, and then unpause all the controllers. So there's some interesting things going on to make that work, but that's how you would basically manage that initial cluster. If you wouldn't be using the kind one.
Okay, so I think that we are almost out of time. The last question is there an Octant plugin for Cluster API? We've seen you using Octant, so.
I think someone might have written one. I'm not sure though. I'm pretty certain someone has written one and it might be on the main list. I should know that answer, sorry. So apologies to whoever has written that.
Okay, great. So thank you, Katie. Thank you, Naadir, for a great presentation. It was awesome, really. And that's all the questions we have time for today. So thanks for joining us today. The webinar recording and slides will be online later today. And we are looking forward to seeing you at a future CNCF webinar. So have a great day, everybody. Thank you.
Thank you, everyone.